Hello and welcome. Welcome back to Research Methods. This week we have a short set of slides here. There's 14 of them, and we have maybe one or two extra videos. The reason that we have a short class is that the topic for this week is important and often difficult to understand. So we're going to be looking at reliability and validity. And just to give you a very brief introduction, reliability and validity are the ways that we as scientists assess whether or not what we're doing actually makes sense. They're kind of our permanent struggle to step back and think about, are we doing something that is useful and meaningful, or are we just kind of spinning our wheels? So the three sections for this week, each one of them is going to be pretty short, just a couple of slides. First, we're going to look at what reliability and validity are, and then we'll look at a couple different subtypes of reliability and validity. You could divide them into infinite subtypes, but I'm just going to show you a couple subtypes so you get an idea of how you could think about that. And then we'll have just a brief section on why this is so important. And it'll be a lot easier to understand why it's so important as we go along, because we'll have lots of little examples that'll make it make sense in a real world kind of way. So let's start with, what are reliability and validity? The definitions for themselves are really not that complicated. Reliability is consistency, whereas validity is accuracy. So uh, let's just describe this first with a quiz. So you've probably taken a quiz like this before, some sort of personality test that goes, which Harry Potter book are you, or which Harry Potter Hogwarts house are you? And the thing is, you can take these tests and they can give you some sort of answer, but you want to think about, does that answer really mean anything? So the way that we can assess whether the answer means something is by thinking about its reliability and validity for the test. So let's say that we're thinking about, is this test reliable? So if you take this which Harry Potter book are you quiz, and it has any sort of meaning to it, then the same person should get the same result over and over and over again. And that's reliability, that you can get the same result. Not just that, but say, let's say that three or four people are all definitely the first book, The Sorcerer's Stone. And if you give the test to all four people, let's say we somehow know that they are definitely that book, and you give the test to all four people, but two of them get that book and two of them get other books, then it doesn't seem as though the test is very reliable. Let me give you another example of reliability. So my friend of mine, Anton, has is doing some research where he can get you to play a game on the computer, and then just based off of how you move your mouse, the computer has a program that's supposed to be able to guess, are you male or female, what age group you're in, and do you have signs of ADHD. And so this is an interesting set of research, because it would be cool if teachers could identify whether online students were not just, were they the people that they're supposed to be, like, are they taking a test for somebody else, are they cheating, or also do their online students have signs of ADHD, or just signs that they've lost attention in what they're doing. So you can imagine that that sort of program needs to be very reliable. It needs to consistently and correctly identify whether the person is male or female in the age group, and whether they have signs for ADHD. So reliability, again, is consistency. The next one is validity. So back to our Harry Potter test. One question you can ask yourself is, how do we know that this test is actually telling us something meaningful? Did they get the questions from the author? J.K. Rowling, that would make it valid because the author could probably come up with questions that would assess that. Did they talk to one of the imaginary characters? Did they talk to the Sorting Hat and see, can we get information that way? One of the best ways to check if the test was valid is if we could get some actual. So let's say we had a test of. Let's say we had a test of whether or not you were a Gryffindor or a Slytherin, part of one of the groups of the Hogwarts house. And so the best way to check if the test was valid would be to have those children take the test, and then if the test told them you are in Hogwarts and they were Hogwarts, then you know it's valid. If you had them take the test over and over and over again and they consistently got the same answer, that's reliable. And so this is where things get a little bit confusing, because it's important to know that you can be reliable without being valid, but you can't be valid without being reliable. I'm going to go back here to this slide to try and explain that idea. So let's imagine that this target is a circle representing how accurate and how good our research is that we're doing as scientists. And so you shoot your science arrow at it, you do experiments and come up with theories, and when you do those experiments, you gather data. So data that looks like this is going to be reliable but not valid. What does that mean? Well, we're definitely not hitting the bullseye, so we're not valid. We're not actually getting the information we're looking for. However, the information we're looking for is very consistent. And because it's consistent, it's reliable, but not valid. Over here, we have a situation that's neither reliable nor valid. And you could see that there's no way that we could ever hit the bullseye in a meaningful way, because our shots are so inconsistent that if we hit the bullseye, it would have just been luck. Here's your good reliability and good validity. Here's somebody who is shooting on target. They're accurately hitting the bullseye. And so they're hitting the bullseye, that's validity, but they're hitting the bullseye every time. That's reliability. So does it make sense that you can have reliability, consistent results, without validity, accurate results? Let me give you one more example, and in the next section we will actually, we have a couple more examples here. So another set of examples you could think about for reliability and validity is when you measure things with rules of thumb. So it turns out that the phrase rule of thumb comes from the fact that your thumb, from the tip of your thumb to that first knuckle, is about an inch. And so you can use your thumb to roughly estimate the size of things. It's almost like a teeny little ruler. Now, is your thumb going to be exactly 1 inch? Probably no. What I'd like you to do, if you'd like, is grab a ruler and measure the length of your thumb from the tip of the finger to the knuckle. And the thing is, it's not going to be exactly 1 inch. So it's not going to be super duper valid, because it's not perfectly measuring what it's trying to measure, an inch. But it's not going to be terribly far off either. Maybe it's like 3/4 of an inch or 1 1/4 inches or something like that. So not super far off. Now, let me ask you this question. See if you can answer this on your own. Is that rule of thumb going to be reliable? Think about it for a second. We know it's not valid because it's probably not exactly 1 inch, but is it going to give you reliable results? It definitely will, because your thumb is not really going to change size very often. So the results that you get are going to be pretty consistent. So your thumb is going to be a reliable and mostly valid way to measure an inch. And so we have these other types of measurements in our that we could use as rules of thumb. Some of them they're all going to be pretty reliable. Uh, say uh, measuring 4 inches as the length across your hand. We know that your hand's not going to be exactly 4 inches across, so it's going to be valid, but not too valid. So kind of valid. What about, is it going to be reliable? Well, think about it this way. I want you to straighten your fingers so that you have them all across, and move your hand. Say open and close it a little bit, make it flatter, make it wider. Notice that you can actually move your hand in a bunch of different ways so that even though you're trying to hold your fingers straight, they kind of change size. And so, because it's difficult to get a consistent measurement across your fingers, maybe it's also a little bit less reliable. Next up, a dollar is supposed to be 6 inches across. That's going to be super duper reliable because dollars are going to consistently be the same size unless you have a fake or one that got ripped up. Is it going to be valid? It probably is going to be very valid because they probably made dollars to be 6 inches across. Actually, I'm not sure if they actually are 6 inches across, but you get the idea. You can imagine how reliable or valid these two measurements in the bottom are going to be. So if you'd like, I'd really encourage you to check it out and see if you can come up with your own conclusions on their reliability and validity. Okay, so I'm going to have one more example for you. This is a short video. You don't have to watch the whole thing, but this guy is a beefy guy, and he's trying to explain to you how to buy scales at the store to weigh yourself if you're trying to get fit or put on muscle. So I'm going to stop the video here, and I'd like you to watch that video, and then we'll come back with a bit of a reaction just to make sure that you understand what parts of the stuff he was talking about were reliability and which parts were validity. And so what I'd like you to do is think about, is he talking about reliability or is he talking about validity? He talks about both in the video, but he doesn't really mention them by name. And I'd also like you to write down the numbers that the scales give him for his own weight. So go ahead, give that a shot, and we'll come back in just a few minutes.